My dear students, in a previous video, I have solved some problems in the exercise 5.5. On the continuation, I am going to solve the same exercise, few more problems in the exercise 5.5. The problem number 7 in the exercise 5.5 is, I am going to solve the problem number 7. A rod of length 1.2 meter moves with its ends always touching the coordinate axis. See, you know these are the coordinate axes. This is y-axis and this is x-axis. This is the origin. Problem states that a rod of length 1.2 meter moves with its ends always touching the coordinate axis. This is the rod. AB is a rod. It touches the coordinate axis and moves along the coordinate axis. So it moves in this direction. The rod moves in this direction. So B moving downward and A moving on the right side. Like that, the rod AB is moving in such a way that in the coordinate axis OA, in the direction of OA is A travels, and BO, the point, the rod end of the B travels towards origin, and A moving out of the origin, away from the origin, I mean. So AB is a rod of length 1.2 meter. The length of the rod is 1.2 meter. It is given by 1.2 meter. The length of the rod AB is a rod whose length is 1.2 meter. And it touches the coordinate axis. The ends are touching the coordinate axis. The locus of a point P on the rod, which is 0.3 meter from the end of the end in contact with x-axis. So this is the length is 0.3 meter from the end A. The point P x comma y is a point P on the rod. From the end of distance 0.3 meter, the point P is described. 0.3 meter from the end of the head A, the point P x comma y is on the rod, and the locus of the point P, when the rod moves along the axis, it describes an ellipse. The point P, the locus of the point P describes an ellipse. If it moves like that, the point P describes an ellipse. We have to find out the eccentricity of the ellipse. That is the problem. Ellipse, find the eccentricity. That is the problem. See, P x comma y is a point on the rod. From the end A, it is 0.3 meter. Therefore, the remaining end is 0.9 meter, because total length is 1.2. 1.2 minus 0.3 is 0.9 meter. So BP is 0.9 meter, AP is 0.3 meter, totally 1.2 meter. Okay. The point P x comma y, see, if you draw the line parallel to the x-axis, this distance is x and this distance is y, because point is, this is x, therefore the distance is x, and this is y, coordinate of the point, this is y, therefore the point is y. See, this is the point PD and PC. PC is distance y and PD is the distance x. P x comma y is a point on the rod. Now we have to find out the locus of the point P. It describes the ellipse, and the eccentricity of the ellipse we have to determine. Now we have the two triangles. What is that? PBD and APC. We have the two triangles here. See, angle D in the triangle, this is angle D. So similarly, this is right angle. Angle C is right angle, and D is also in the triangle PBD. D is the angle right angle. Similarly, in the triangle APC, C is right angle. And these two angles are equal. Angle B and angle P are equal. Why? Because OB and PC are parallel lines. OB and PC are parallel lines, AB is a transversal. If the two parallel lines cut by a transversal, the same angles are equal by the property of parallel lines. If the two lines are parallel and this is a transversal, if two lines are parallel like that and this is a transversal, so transversal means it cuts the two parallel lines, therefore the angle, these two angles are equal because same angle. Therefore, angle P and angle B is also equal because same angles. Therefore, automatically the third angle, this one, and angle P and angle A are automatically equal. So, in the AB problem, AB is the rod of length 1.2 meter, P, X, Y, B, any point on the rod, whose distance from the end A, that is AP, equal to 0.3 meter, therefore BP equal to 0.9 meter because total length AB is 1.2 meter. AP is 0.3, BP is 0.9. Therefore total AB is 1.2 meter. Now angle PBD, triangle PBD and triangle APC, triangle PBD, triangle PBD is similar to triangle APC. Why? The three angles of the two triangles are equal separately. AAA property, by AAA property. All the three angles are separately equal to all the other triangles in the other triangle. Because angle B equal to angle P and angle A equal to angle P and D equal to C, because these two are right angles, and angle DBP and CPA are equal because they are same angles of parallel lines, and BPD and PAC are also equal because the third angle is automatically equal. Therefore, by AAA property, these two triangles are similar. Therefore, the sides are proportional. Therefore, the sides are proportional. Their sides are proportional. See, up in this triangle, bigger triangle PBD, the angle opposite to the side opposite to the angle B is PD. Similarly, the same angle opposite to the side in the other triangle is CA. PD by CA equal to opposite to right angle in the triangle PB by opposite to right angle in the triangle PC. So automatically the third angle, that side, angle opposite to P, BD by angle opposite to side PC. So these two triangles are similar by AA property, therefore the sides are proportional, therefore angle opposite to B is PD by CA equal to, what is that? Hypotenuse PB by the hypotenuse PC, and the other side PD by PC. BD by PC. So now PD, we know PD is X. Distance PD is X. CA, we don't know. We write it by CA. PB we know 0.9 millimeter, sorry. And PC, PB 0.9. Side opposite is AP. PB by AP, I'm sorry. This is hypotenuse for this triangle is PB, hypotenuse for the triangle is AP or PA. PA is 0.3 meter equal to BD. For this BD we don't know, but PC we know why. So comparing from this with two unknown CA and BD we can determine 0.9 by 0.3 is 0.9 by 0.3 is 3. 3 by 1 I mean actually. 3 3s are 9. 3 by 1 equal to BD by Y. Here X by CA. Comparing these two, X by CA equal to 3. X by CA equal to 3. X by CA equal to 3, therefore CA equal to X by 3. Cross multiplication, CA equal to X by 3. So CA we determine this is X by 3. Okay. And comparing these two, BD by Y equal to 3. Similarly, BD by Y equal to 3, BD equal to 3Y. From this implies BD equal to cross multiplying 3Y. So BD is 3Y. We determined unknown CA X by 3 and BD 3 by 3Y. And this is also Y. OD is Y. So after determining the unknowns BD and CA, we from the triangle OAB, bigger triangle, right angle triangle OAB, OA square plus OB square equal to AB square by Pythagoras theorem. Now we are going to see that step. Next, after determining this, in the bigger right angle triangle OAB, next in the right angle triangle OAB, OA square equal to OA square plus OB square equal to hypotenuse AB square by Pythagoras theorem. OA square plus OB square equal to AB square. OA, what is OA? X plus X by 3. OA square is X plus X by 3 whole square plus OB square. OB square is OD plus DB, Y plus 3Y. Y plus 3Y whole square equal to AB square. AB square is 1.2 square. By Pythagoras theorem, OA square is X plus X by 3, OB square is Y plus 3Y whole square equal to 1.2 square. This is 3x plus x, 4x by 3 whole square. 3x plus x, 4x by 3 whole square, this is 3y plus y, 4y whole square equal to 1.2 whole square is 1.44. So this is 16x square by 9 plus 16y square equal to 1.44. Now x square by, on rewriting this, you will get x square by a square, standard form of the ellipse is x square by a square is 9 by 16 plus y square by 1 by 16. Y square by 1 is here. Therefore, x square by 9 by 16 plus y square by 1 by 16 equal to 1.44. So x square by a square plus y square by b square equal to 1. We have 1 here, but we have 1.44 on the right hand side. So you divide by 1.44. You will get x square by 9 into 1.44 by 16 plus y square by 1 into 1.44 by 16 equal to 1. So this is of the form x square by a square plus y square by b square equal to 1. X square by a square plus y square by b square equal to 1. A square is 9 into 1.44 by 16, b square is 1 into 1.44 by 16. This is the standard equation of the ellipse. From this we are going to find out the eccentricity by using the eccentricity formula. Eccentricity E equal to root of 1 minus b square by a square. This is the formula for eccentricity. Substituting the values of b square and a square, you will get the eccentricity. That is our required question of the problem, required problem. So next, eccentricity E equal to eccentricity E equal to root of 1 minus b square by a square for ellipse. So this is equal to root of 1 minus b square. 1 b square is 1 minus b square is 1 into 1.44 by 16 by a square is 9 into 1.44 by 16. This is your square root value. This 16, 1.44 cancel, both the numerator and denominator. 1.44 cancel, 16 cancel, you will get 1 minus 1 by 16. Sorry, 1 minus 1 by 9, sorry. 16 is also, get these quantity cancel, you will get 1 by 9. 1.44 by 16 cancel on both numerator and denominator, you will get just 1 by 9. By taking LCM as 9 minus 1 is root of 9 minus 1 is 8 by 9. So eccentricity is E equal to root of 8 by 9. Square root of 8 is 2 root 2. Square root of 8 is 2 root 2. Square root of 9 is 3. So eccentricity equal to 2 root 2 by 3. This is our required answer. That's all about the problem. Okay. This is problem number 7 in the exercise 5.5. Okay. Next, one more problem. 6th problem in the exercise. We will see the next problem. Cross section of a nuclear cooling tower is in the shape of a hyperbola with equation x square by 30 square minus y square by 44 square equal to 1. The lower is 150 meter. The tower is 150 meter tall, and the distance from the top of the tower to the center of the hyperbola is of the distance from the base of the tower to the center of the hyperbola. Find the diameter of the top and the base of the tower. That's all the problem 16. The 16th problem is sixth problem. Next in the exercise is 6th problem. Next we will see the problem number 6 in the exercise. So 7th problem is somewhat some difficult problem. By using the similarity property of the triangles, we are going to derive the eccentricity. Next, problem number 6 in the exercise. Problem number 6 in the exercise is the cross section of a nuclear cooling tower is in the shape of a hyperbola. See, cross section of a nuclear tower is in the shape of the hyperbola. This is the center of the axis. See, nuclear cooling tower is in the shape of a hyperbola with equation x square by equation of hyperbola is 6th problem. X square by 30 square minus y square by 44 square. Y square by 44 square equal to 1. This is the equation of the hyperbola of this nuclear tower. It is in the form of hyperbola. The tower is 150 meter tall. The total height of the tower is 150 meter. The total height of the tower is 150 meter. Height of the tower 150 meter. It is given. Tall, and the distance from the top of the tower to the center of the hyperbola is of the distance from the base. See, the total is 150 meter. See, this is 150. Total distance is 150. So the top of the tower is from the center, top of the tower to the center of the hyperbola is half the distance from the base of the tower. That means here this is 50 of the distance, 50 meter. The lower is 100. Therefore, this is half. Total length of the tower is 150. Out of which higher upper of is half of the base. Therefore, this is 100 meter. So, tower center of the hyperbola, the distance from the base is the base of the tower to the center of the hyperbola. Find the diameter of the top and base of the diameter of the top and the diameter of the base. These two diameters we have to determine. This is from radius and this is from. We have to find out the diameter of the higher base and the top. Equation will be the equation. So this is the point on the hyperbola whose distance is, we don't know this distance by x and this height by x comma 50 is a point on the hyperbola. X comma 50 is a point on the hyperbola. Therefore, x comma 50 upper of, in the upper of x comma 50 is a point on the hyperbola. Therefore, x square by 30 square minus y square is 50 square by 44 square equal to 1. 50 square by 44 square equal to 1. So, for convenience, you write it as x1 square. So, this is x1 square by 30 square equal to 1 plus, this terms become, right hand side becomes plus 50 square by 44 square. This is x1 square by 30 square equal to 1 plus 50 square by 44 square. So this is equal to 1 plus 50 square is 2500. 44 square is 1936. Okay. And x1 square you want. x1 square is equal to 30 square is 30 square into denominator. This is what is that? 1 plus 2500 by 1936. This is 30 square is expressed as 900 into 1936 plus 2500 by the denominator 1936. So this is on simplification. X1 square is equal to 45.41. From this you get x1 equal to 45.4. So the distance x1 equal to 45.41. But the diameter we want, for that the total distance 2 times of this is the radius, therefore 2x1. Therefore diameter of the upper half is, diameter of the upper half is 2 times of x1. So x1 is 2.51. Therefore the diameter of the upper part, upper circle is 2x1, that is equal to 2 times of 45.41, that is equal to 2, 2 4s are 8, 90.82 meter. 90.82 meter, that is the upper half of the diameter of the upper part of the tower. Similarly, lower part, diameter of the lower part you have to determine the same way. You consider this is by 100, you consider this by x2, the total distance is 100, x2 comma 100 is a point on the x2 comma 100 is a point on the hyperbola. In the place of this, we will consider the same equation. If you consider this x2, for that you get x square. Similarly, for finding the diameter of the lower part, x2 square by x2 square by 30 square minus y is 100 square by 44 square equal to 1. From that you get x2 square equal to 30 square into 1 plus 100 square by 44 square. So on simplification, x2 this is by simplifying, you will get x2 equal to from this you get x2, on simplification you get x2 equal to 37 point and 3 for example. This is total diameter we want 2x2. The diameter of the lower part of the tower diameter of the lower part of the tower is 2x2 equal to 2 3s are 6, 2 2s are 4, 2 7s are this is 7. 75.46, 75, 74, 37.236, 2 7s are 14. So lower part, diameter of the lower part is 74.46 meter, upper part is 90.45, sorry. This is a, total 2x1, this is not 90, the 2x2 is 45.4. 2x1 is 45.41, x1 is 24, from this x1 is 22.71 or 72. 70, right. Multiplying by 2 you get 90.482. This is multiplying by 2, this is 2 1 is to 40, 45. This is 2x2. So single diameter radius is 22.7. I have given us radius itself is 45.4. You calculate this is radius is 22.71 or otherwise 7. Multiplying you will get 45.4. So this is the diameter for the upper and this is the diameter for the lower part. So x1 is 22.71 and the simplification in the previous step I gave 45 point, that is only 22.71. On multiplying by 2 you get 45.4. That's all about the upper and lower diameters of the cover. And one more problem, the last problem in the exercise is 10th problem. There are 2 points A and B are 10 meter apart, and this diameter from the sound, see, the 2 points A and B are 10 meter apart, and it is determined from the sound of an explosion heard at those points at different times that the location of the explosion is 6 kilometers closer to A than B. See, this problem you will see, 10th problem. See, 10th problem. This is center part of the origin, and this is A and this is B. There is an explosion. This is the point P. See, what is given in the problem? Points A and B are 10. Point A and B are 10 kilometers apart. Distance between 2 points A and B are 10 kilometers. This is 10 kilometers. Therefore, this point is x is minus 5, 0, and this is plus 5, 0. C is the origin, center. 5 plus 5 is 10 kilometers. Therefore, the point on graphical representation, this point A is minus 5, 0, y coordinate is 3, y coordinate is 0, therefore this is 5, 0. And P, at the point P, there is an explosion here. At different times, the location of the point P is 6 kilometers closer to A. This is AP and BP. Difference is, the AP difference BP is 6 kilometers given. There is an explosion happened here at the point P. The difference between the explosion from the point A is 6 kilometers A to B. This is by a property of hyperbola. Focal distances, differences of the focal distances is 2A. 2A equal to 6 kilometers, A equal to 3. The difference of focal distances, because A, B are focus. A and B are foci of the hyperbola. C is the center of the hyperbola. So the difference of the focal distances is 2A. 2A equal to 6, A equal to 3. And similarly, we have to find out the B. AB, AB is focal distance. AB is 2AE. AB is the focal distances. It is given by 2AE. It is 10 kilometers apart. They are given. The difference between two foci is 2AE. Therefore, you get AE equal to 5. B square equal to, A square E square minus A square. By hyperbola, B square is A square E square minus A square. A square E square is 5 square. Minus A square is 3 square. This is 25 minus 9 equal to 16. B square is 16. A square is 9. Therefore, equation of the hyperbola is x square by A square minus y square by B square equal to 1. X square by A square is 9. X square by A square is 9 minus y square by B square is 16 equal to 1. This is the required equation of the hyperbola. That's all about the problem. This is problem number 10. The focal distances. This is the concept. The difference of the focal distances of hyperbola is the length of the transverse axis 2A. Therefore, from this idea, I got A, and by AE, focal distance is 10. 2AE is 10, AE is 5. From that, I get B. B square is 16. Substituting here, we get the equation of the hyperbola. That's all about the problem. Thereby, I conclude the exercise 5.5. Okay, let us stop the video here and we will continue the next topic in the next video. Thank you.